This video serves as a review of operations on rationals and also solving rationals. So, in no particular order, these are the things that we'll be reviewing. So, take a second, go ahead and give these two particular problems a try. As a reminder, you need to resolve the power rule of exponents first. So, power to a power, you multiply the exponents. And whenever you're multiplying, if the bases are the same, you add the exponents. And whenever you're dividing, as long as the base is the same, you subtract those exponents. And then the end, you'll need to deal with any negative exponents that you might get as a result. So go ahead, pause the video right now, give these two questions a try. All right. So let's see what we get here. So I see power to a power, and we need to remember that anytime a power is not written, that it is a 1. So we have 2 to the second power, which would be 2 squared, so we have 4. And then we have x cubed squared, which would be x to the 6. And then we'll just leave the bottom, nothing to do there. And then nothing really to do here. And now what I'll do is I'll go ahead and multiply the top and the bottom. Before doing so, I'll go ahead and reduce. So the 7 cancels the 21. And the 4 cancels the 16. And we need to remember when we cross cancel, we do get 1s here, not 0s. And now we get top times top and bottom times bottom. So 3x to the 7 y squared all over 4 x to the 11 y to the 4th. Now, I'm not done. This is divide, so I need to subtract my exponents, and when I do get negative exponents. So 7 minus 11 is negative 4, and 2 minus 4 is negative 2. So I need to drop those both to the denominator, and you can think of it as there's more x's and y's in the denominator anyway. So that's where they should end up, thus giving us our final answer here. For division, we need to flip the second fraction as our shortcut. We also have power rule to go ahead and deal with. So I'm going to do those things simultaneously. So 3 cubed is 27. And then we have x to the 12th, y cubed. Now we switch to multiplication. And this is going to flip, so I have the 9 x to the 5th, y to the 6th at top. And then I have 16 x squared, y squared at the bottom. Now I cross cancel. So divide by 8 and divide by 9 right here. And now tops times top, bottom times bottom. So I can't even read, that's a 1. All right, so I have x to the 6, y to the 7, adding my exponents, and then x to the 14. I do have a 6, 3 times 2, 6, and then y to the 5th. Now I subtract my exponents. At top I have my 1, my 6, so negative 8, so I have x to the 8 at bottom. And then 7 minus 5, so that's 2, so y squared at top, thus giving my final answers for those. All right, now with addition and subtraction, we do need a common denominator. So we want the least common denominator. Let's go ahead, pause the video right now, and give these two a try. And let's go ahead and see what we get. We need, so this denominator has x squared. So I know I need 2 x's down here. This one has a single x, so it'll be taken care of by that x squared. This has a single y, but this has y cubed. So this y is taken care of by this y cubed. So now what I need to think is, what do I need to multiply top and bottom of this fraction by to go ahead and get the x squared and the y cubed? And that would be y squared. So I multiply top and bottom by y squared. That'll give me this denominator, so I get 4y squared plus. And then this one, I'm missing an x from this. So top and bottom times x, so that gives me 3x. I could rearrange the terms, but ultimately this is my answer. No reducing. I can't cancel these y's or these x's. You can never cancel through an addition or subtraction sign. Only if you're multiplying does canceling apply. On this one, I have a single x and x cubed, so x cubed, and then I have 4y, or y to the fourth, and then y, so y to the fourth. And now 2a times, now what's this denominator missing? Well, it's missing x squared. So I multiply top and bottom by x squared. So I get 2a x squared minus, and then this one is needing a y cubed. If I multiply top and bottom by y cubed, that gives me this x cubed y to the fourth. So 7a y cubed. These are not like terms, so I cannot simplify them. Okay, continuing, so we do need to remember to factor to find our common denominator. So that's not going to apply in this first example, but it will apply in the second example. So pause the video right now and give these a try. All right. And on this first one, our common denominator is the grouping x plus 3, x plus 4. So this one is missing the x plus 4. So I'm going to have x plus 2 times x plus 4. I'm going to need to watch out for this minus. So I want to make sure I finish my multiplication before distributing it. And I have x plus 3 because this denominator is missing the x plus 3. So now I multiply out and I get x squared. Now I'm just going to work on my numerator a little bit to save some space. So I'm just multiplying this out. Don't drop your parentheses until you're completely done with all distributing. And now we'll distribute this negative. So all those need to switch. So the first set of parentheses ultimately don't matter. And now I combine my like terms. The x squareds cancel. And I have 6x minus 2x, so that's 4x. And then 8 plus 3 is 11. Now, if I could factor that, I would, to check to see if it cancels with my denominator. It does not. So I am done, and I might want to make a note here that x could not be negative 3 or negative 4, because that would make our denominator 0. And if we have a 0 denominator, that's bad. All right, on this other one, I'm going to go ahead and factor. Get x plus 4, x plus 5. And right here, x plus 4, x plus 3. So that makes my common denominator x plus 4, x plus 5, and x plus 3. So I need to multiply this top by x plus 3, because this denominator is missing the x plus 3, plus. Now I want to, do not be lazy, do not just drop parentheses. This one's missing the x plus 5. Now I'll multiply out, so I'm just going to work on my numerator a little bit, just to simplify it. I'll multiply this out. And now I combine like terms. So I'm continuing just working on my numerator. I get 2x squared plus 15x plus 36. And then I'll put back my denominator. And again, we would note we can't have negative 4, negative 5, or negative 3 as the value of x, because that screws up our denominator. Again, if I could factor this numerator, to see if anything cancels down here, I would do so, but it does not. Okay, when we're multiplying and dividing, it's pretty much easier than addition and subtraction. But you do, again, need to remember to factor. Look for any canceling. And tricky factoring over here on the second one, so just watch out. Remember to factor out the common thing first. So pause. Go ahead and give these a try. And let's go ahead and factor. So the first one, I have x minus 5, x plus 4. And in the denominator, x minus 6 plus 6. Now, we're dividing, so we switch to multiplication. We'll flip, and I'll do that step. Nope, that's a mistake. There should be x plus 6 and x plus 2. Always check your factoring. So 6 times 2 gives me the 12, and 6 plus 2 gives me the 8. Alright, and then we factored that numerator, which is now in the denominator. Now I cross cancel. See, I have multiplication, so I can cross cancel. And then that gives me the final answer. So top times top, bottom times bottom. And there we go. And again, x cannot be 6 or negative 5. Now on this one, some tricky factoring. So if I look at this numerator, I can factor out a 4x. So that gives me x minus 2, which doesn't factor any further. Now this one, I see I can factor out an x. It's just saving myself some space. And then I could factor this little piece further. So this all multiplies to give me this denominator. So look for that common thing. In this case, the x could come out. So I do that first, and then I continue factoring. Don't try to do it all at once. Little steps. On this one, I can factor out an x and nothing else. And on this one, if I factor out an x squared, I get x squared minus 4, which continues to factor. So I have x squared on bottom, then x minus 2, x plus 2. So now look for some canceling. So the x minus 2's cancel. These x plus 2's do not cancel, because they're both in the denominator. The x minus 1's do cancel. Now I'll do top times top, bottom times bottom. So I get 4x squared all over. Now I'll get x times x squared is x cubed, and then I have x plus 2. I have 2 of them, so x plus 2 squared. Now, I'm not done. I see these, so quotient rule applies. Now, I could, of course, canceled them up here. Like, I could have canceled these x's and one of these, but I find that that gets pretty sloppy when you just have a single variable, so I like just multiplying it out, then using quotient rule, but as long as you reduce this at the end, so 2 minus 3 quotient rule, we get negative 1. So I have an x at the bottom. And we would note that x is not 0 or negative 2. Okay, continuing, doing pretty good. Now, this is pretty tricky. I have a division with an addition and a subtraction inside of it. So the trick to a question like this is to do the numerator, do that addition, do the denominator, do that subtraction, and then do the division last. So you should combine these, then divide. So give it a shot, pause. Okay, and let's see how you did. So I'm going to work on this numerator first. So I need a common denominator. It's x. So this needs to multiply by x. So it's like 1 over 1. And then this doesn't need any multiplication, it already has the common denominator of x, so I get that in that numerator. And then I'll work on this denominator, and basically the same thing happens. This is 1 over 1, and my common denominator is x. So top times x right here to get that common denominator. This already has an x, so minus 1. And now I can go ahead and keep the first fraction, switch to multiplication, flip the second fraction, and then I see that these x's right here will cancel, giving me x plus 1 over x minus 1. And x is not 1. So a lot of steps there. So when you have addition and subtraction mixed into a big complex fraction, go ahead and do that addition and subtraction first, as it's a different problem, and then put it all together at the end. So this will work similarly. We need a common denominator in our denominator, so I would work on this piece first, and then put it all together at the end. Nothing to do up here. So pause, give it a shot. And let's go ahead and try this. So I'm just working on this denominator. And I see that my common denominator is 3 times x minus 1. This is missing the x minus 1, so I'm going to need to multiply the top and bottom of it by x minus 1. So that gives me x squared minus 1 when I'm done multiplying that out. Now plus, this is missing the 3, so I'd multiply top and bottom of that by 3. That gives me 12. And when I combine, I'll get x squared minus 11 all over 3 x minus 1. I don't want to multiply that out. So I'll go ahead and bring this back. So basically this is this thing right here. So keep the top, flip the bottom. The bottom is this. So we'll have 3 over x minus 1. And then the denominator is x squared minus 11. So the x minus 1's cancel, giving me 3 over x squared minus 11 as the final answer. And we would say that x is not root 11, because if I square that, I get 11, and 11 minus 11 is 0, so we couldn't have that. If you didn't see that, this is why. Because if this x squared is 11, then 11 minus 11 is 0. Okay. I know those are pretty involved, so we'll do another one. So nothing to work on this numerator, but I do need to work on this denominator. So pause the video, give it a shot. And let's go ahead and work on this denominator, but first, I'm going to go ahead and factor. I meant denominator there, if I didn't say that. Let's factor this numerator, though. And let's see, 3 and x minus 1. Do a check. So there's my 3x minus 2x. Gives me x. So that's good. So the question is, what's in this denominator? Well, let's work on that over here. I need a common denominator. It is 6. So this needs a 2. So 2x. And this needs a 3. So plus 3. So I'll have 2x plus 3 over 6. Now I keep and then flip. So I have 2x plus 3, x minus 1, times, flip this, now if this confuses you, this is over 1, and then these cancel, and I basically get 6x minus 6. No restrictions. All right, getting into the home stretch, so we have 3 more questions. These will be solving. So with solving, as long as we have an equality, If we have anything else than an equality, less than, greater than, any of that, what we're doing here would not work. But if we have an equality, it does. So what we want to do is we want to factor, multiply both sides of the equation by what would be our least common denominator, and then cancel out the fractions. So pause and give this a shot. And we start by factoring. Of course, if you factor in properly, that does make these you're more liable to get stuck. So double check your factoring; it's worth that. So I factored all the denominators. So now I'm going to multiply top and bottom by the least common denominator. So I have x plus 4. Now I see that that would also cancel this. And then I have an x minus 1. That'll cancel this. So this is good. And then I need an x plus 1. So I multiply both sides by this entire group, and it's going to distribute to each one of these fractions. So I have this x times, and then the x plus 4 and x plus 1 would cancel, leaving me x minus 1. This whole group then distributes over here, and the x plus 1 and x minus 1 will cancel, leaving me with x plus 4. Now I copy down my plus, and if this were a minus, I'd want to be extra careful. And then the x plus 4 and x minus 1 will cancel, leaving me with an x plus 1. Now I distribute. And I'll combine like terms. So I get x squared plus 4x plus 12. When I subtract everything over, the x squareds will cancel. So if I add this x, I get 5x plus 12 equals 0. Why do I feel like I made a mistake somewhere here? Oh well. Anyways. Oh well. Yeah. For some reason I remember doing this and getting something different earlier. But okay, I'm sure someone will say something if I did that wrong. For some reason, I was thinking I was supposed to get negative 4. So, I don't know what happened, but it's whatever, I suppose. Now, we do need to check to make sure that we didn't get part of our restriction. So if I look back up here, I would note that I can't get negative 4, negative 1, or 1. If I'd gotten any one of those, I would have to reject that answer. Now, it just so happened in this case that I did not, so everything worked out fine. Okay, so on these last two solving, you will need a calculator to help, because we're going to get some cubics, and you should know from a previous chapter with polynomials that in order to solve high degree polynomials, you need to find the roots. You can do that with just synthetic division and guess and test, but we're going to use the calculator to help us to know where those roots are. So go ahead and pause and give this a shot. And no factoring involved here. I just need to clear by multiplying by x minus 9 and x plus 3. So at the left, I have x squared times x plus 3, because the x minus 9s would cancel, plus x times, we'll get x minus 9, equals, and the x minus 9s cancel, and the 6 will multiply into x plus 3. So I just distribute, and keep going down the line. Now I'll get everything to one side. This will be 4x squared. When I subtract the 6, I'll get negative 15x, and I subtract the 18. So I do have a cubic, so I'm going to go ahead and graph it. Now I'm going to go ahead and note I can't get -3, nor can I get 9. If I get those, it's wrong. So when I do my graph, I see that 1 works. 1 is one of the roots. So I'm going to do my synthetic division. And I confirm it's a root if I get a 0 over here. So the 1 drops. Okay, I did not get a 1. Why did I not? Okay, I have 3 written down. Maybe that'll work. Let's try 3. 21. 6. Okay, so 3 works. I don't know why I wrote down that 1 worked. Okay, so here we go. Now at this step, we've divided 1 time, so we have x squared plus 7x plus 6, which does factor to x plus 6 and x plus 1, so it was -1. So I could do that and say that x is -6 and x is -1. I could also do synthetic division, like I could continue my synthetic division and use -6. And then I could do the -1. In any event, though, I get x equals -1, -6, and 3. Now, if this 3 had been -3, I'd have to reject that. All right, and the last example, factoring involved this time, and you will need the calculator to help. So go ahead, pause the video. And we factor. And we're going to clear our fraction by multiplying by our least common denominator of x plus 9 and x minus 1. And that gives me -31 plus x squared times the x minus 1 here will cancel, so I have x plus 9 times x plus 3 and the x minus 1. So I get x squared plus 2x minus 3 over here, and -31 plus x cubed plus 9x squared over here on the left. We'll get everything on the left. We like to keep our highest power of x positive. So when I subtract this x squared, I'll get 8x squared. And when I subtract this 2x minus 2x, and when I add the 3, I get minus 28. Okay, I graph this and see where the roots are. I see a root at -2. Hopefully I'm right this time. So we do our synthetic division so that we can get a quadratic down here. So 1, -2, 6, -12, -14, 28, 0. So we got a 0 here. This worked. So this is a quadratic where A is 1, B is 6, and C is -14. So I'll use the quadratic formula. So I get x equals -b, so -6 plus or minus the square root, b squared, so 36 minus 4 times a times c, all over 2a, so 2 times 1 is 2. So I get 6 plus or minus square root. Now I would type all of this inside into a calculator, and I think I get 92. And then I simplify that 92. It splits up to 4 times 23. And then I can square root this 4. So I get plus or minus 2 root 23 all over 2. And this 2 divides those two things, so I guess I'll just have to write it over here. X equals -3 plus or minus root 23. And that's definitely not in our restrictions. X couldn't be Fired to check. -9 and x couldn't be 1. Oh, and my 2. Don't forget that. And x is 2. So all of these work fine. No problems. That's it for the review.